We learned about what is blockchain. Now let us dig into the details of blockchain. Blockchain can also be called as block plus chain. So in this video, we'll be learning in detail about the contents in the block. So what is a blockchain? Pictorially, we can represent a blockchain this way. A blockchain will have a block number, the data. Each block will have its own number. All the data in the block will be converted into a hash value. This hash, whatever we have here, will contain, or it's something like a compressed format of the data. Block will have its own block number, data, and hash. Not only that, the blocks are interlinked with each other through this previous hash. Block number 2 will store the hash value of block number 1, and block number 1 will be storing the value of a previous block. Here in this case, there is no block, so this previous hash will be 0. So when new transactions are added to the block will get added as a new block and it will be having the previous hash as well. Since it is a chain of blocks, it is called as a blockchain. There is a block which is created first initially, and this block is called as a genesis block. If the genesis block is created first, then there will not be any previous block, right? So we will have the previous hash as 0. Consider the hash of this genesis block is 0234 ABED4. Basically, it will be a hexadecimal value. And this hexadecimal value will be substituted in the previous hash of the block 2. So this block 2 will have its own hash, including all the hash, this hash also. Hash of the entire block, that is the genesis block, and also the block 2 and the data in the block 2 all together. A final hash will be generated, and this will be added as a previous hash in the next block which is getting added. So when the fourth block comes, then the hash of the third block will be added here. So block in a blockchain will have two parts in it. One is a body part where all the transactions are getting stored, and the header part. A blockchain header will have many values. Already we learned about what is a previous hash. The previous hash will contain the hash of a previous block. The other fields are quite new. The first one is timestamp. Timestamp is nothing but the time at which the particular block has been created. That is the timestamp. Version of the blockchain. We'll be learning in detail about the Merkle root, difficulty target, and also the nonce. When we learn about mining, we learn in detail about what is this difficulty target and what is this nonce, how it works, and how it helps in mining, everything. So what is a timestamp? Timestamp, it is an instance of a time. The time will be mentioned only in seconds. The time will be calculated since 1971, that is 1st January 1970, will be called as an epoch time. When you wanted to verify a particular block, whether that block is a valid block or not, we will check the timestamp. The next comes the version, which includes the version number of the blockchain. Version 1.0 is a cryptocurrency version. Then you've got version 2.0, which includes smart contract, and 3.0 it's dApp, and 4.0 it is blockchain for industry. And we will have further versions getting released as well, because there are a lot of researches that are happening in the blockchain technology. The next one is Merkle root. The Merkle root contains the hash of all the transactions. Each block in a blockchain will have body where you will have all the transaction. These transaction data will be converted into hash. When you have multiple transactions, they'll be combined together to form one single hash, and that single hash will be stored as a Merkle root. Don't worry, we'll be learning about the Merkle root as well, and the working, how the Merkle root is getting created, on a lot about Merkle root. Next comes the difficulty target. Difficulty target is a computational power which is required to mine a particular node in a period of time. And there are a lot of hashing algorithms, or we can say the cryptography algorithms are used in order to maintain this difficulty target. The next one is nonce. It's called as number only used once. That is nonce, which is a 32-bit number which will vary between anywhere between 0 and 2 power 32 minus 1. This nonce value also plays a very major role or very important role in the mining process. The next comes the previous hash. Already we know how the blocks are linked with each other. The blocks are linked with each other through previous hash. So block 2 will store the hash of block 1. When the new block 3 is getting added, the block 3 will store the hash of block 2. And the genesis block will not have any previous value, hence the value will be 0. I'm telling you again and again about hash. So what is this hash value, or how this hash value is getting generated? First, let us see about this hashing. When you have original data, you pass that data to a function and finally you get a hash value. This hash value will be a standard length set of hexadecimal value. And this standard length hexadecimal value is called as a hash value, or it also can be called as a digest. What are the uses of hashing? We have a lot of uses of hashing. We learn about hashing in detail. What is hashing as we discussed? Converting a particular value into a different value of some standard length. How hashing could be used in verifying the password? Now let us say when you store a password directly on the server, the admin who's having access to the database will be able to access your password. Instead, storing the password as such, we can store only the hash value of the password. Whenever a new password is given, you get a hash value of the new password. If both the hash values matches with each other, then the login is accepted. If both the values, in this case, it's different, so the login will be denied. This is what called as a password hash. This is one of the use of hashing where without even knowing what the password is or still maintaining the security of the password stored in the database, we can verify the passwords. There is another use of hashing as well in integrity verification. You have a hash value of a particular file when in the website. You download another file. After downloading the file, you calculate the hash value. If both the hash values are same, then the file is not corrupted. Otherwise, the file is corrupted. Thus, hashing can be used to verify integrity of a particular file. And of course, this hashing is used in blockchain. We learn about how this hashing is used in blockchain in detail in the next video. What is a Merkle root? As I told you earlier, the Merkle root is one of the field in the block header. The hash value of individual transactions will be calculated. This hash of A and hash of B, the combined hash of A and B will be calculated again here. And here we get the hash of C and D. The combined hash of all hash AB and hash CD will be the Merkle root. The Merkle root will have hash of all transactions. What is a nonce? It is a random number. It could be a number which is getting incremented for each transaction. And the nonce is sometimes even used in ordering of transactions in case of Ethereum. Miners guess this value, and that is what called as mining. We have understood the different fields that are part of the block. The block contains the data, not only the data, hash of all data in the terms of Merkle tree root, and it has a previous hash using which the blocks are interlinked with each other. It has timestamp and also it has nonce.